Welcome to Across the Globe. Today we will learn about data frames. Data frames in R are structured as a two-dimensional format that arranges data in rows and columns. Being a fundamental data structure in R, it plays a crucial role in data handling and exploration. Data frames have the ability to accommodate diverse data types like numeric, character, and logical values. An example of this usage could be organizing sales data, where each row represents information about a specific transaction, with columns detailing attributes such as product name, quantity, and total cost. This versatility makes data frames an essential tool for various data manipulation and analysis tasks in R. A data frame in R can be created using the pd.DataFrame function. This function allows for columns with different data types. For instance, a data frame can consist of columns representing names, ages, and genders of individuals. In the provided Python example, a pandas data frame is created with columns name, age, and gender, containing data for 3 individuals. The resulting data frame is then displayed. In a data frame, data is accessed via rows and columns. Columns can be accessed using their names, while rows can be accessed using their indices. For instance, in Python, to access a specific column, you can use print_df_name, and to access a specific row, you can use print_df.IL0, which retrieves the first row. Data frames in Python allow for easy manipulation by adding or removing rows and columns. Columns can be modified by renaming or deleting them. For instance, you can add a new column with data using the syntax df city, New York, Los Angeles, Chicago. Rename a column using df.rename columns age years in place equals true, or delete a column using df.gender axis equals 1 in place equals true. Similarly, rows can be added or removed from the data frame as needed, providing flexibility in data management during data processing or analysis. Think of a data frame like a table in a database, where each row represents a record or observation, and each column represents a different variable or attribute. Just like arranging data in rows and columns in a table makes it easier to organize and analyze, using data frames in programming makes it easier to work with structured data. By manipulating and querying data frames, you can perform various operations like filtering, sorting, and grouping your data just like you would do with a spreadsheet. In a program, you can create a data frame by loading data from a file or database, and then use functions and methods to perform data analysis and visualization on that data frame. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code provided highlights the applications of data frames in R, which is pivotal for data manipulation and analysis. Let's delve deeper into the technical narration of the code. 1. The data frame student data is initialized with columns representing student ID, student name, grade, and age. 2. Print student data outputs the entire data frame, giving a structured view of the student data. Print student data grade extracts and displays only the grade column, showcasing column-specific data access. 4. Print student data doll age 18, filters the data frame to display students with an age greater than 18 using logical indexing. 5. The mean age of students, calculated as average age, mean student data doll age, is displayed using paste to show the average age of students. 6. Data grouping is performed by grade, and the average age for each grade is calculated using the aggregate function. The resulting summary is stored in grade summary and displayed with column headers grade and average age. Data frames are versatile data structures in R, enabling users to efficiently organize, access, and analyze structured data. Real-world applications include handling student records, financial data analysis, and scientific research data sets where tabular representation and manipulation are essential. The code exemplifies the practical use of data frames for data management and analysis tasks in R programming. 2 industrial, real-world examples of using data frames are: 1. Financial analysis. In finance, data frames are commonly used to analyze stock prices, financial metrics, and economic indicators. For instance, a financial institution may use data frames in R to store historical stock prices, company financial ratios, and market data. By manipulating and analyzing this data using data frames, financial analysts can perform tasks such as calculating returns, comparing company performance, and building predictive models for stock price movements. To healthcare analytics. Data frames are essential in healthcare analytics for managing patient information, medical records, and treatment outcomes. Hospitals and healthcare providers often use data frames to store patient demographics, diagnosis codes, treatment plans, and clinical outcomes. By leveraging the power of data frames in R, healthcare analysts can perform analyses such as patient segmentation based on health conditions, evaluating treatment effectiveness, and predicting patient outcomes based on various factors. Across the globe, industries rely on data frames to organize, process, and derive insights from large datasets efficiently. Whether it's in finance, healthcare, marketing, or any other sector, data frames play a vital role in facilitating data-driven decision-making and driving business outcomes. Keep learning, stay curious, and I'll catch you in the next video.